The vast majority of the gas in our atmosphere is actually nitrogen, and yet nitrogen-based fertilizers are an important factor in assisting plant growth. Now, since plants are constantly exchanging gases with the atmosphere, why do they have to get the nitrogen from the soil rather than taking it directly from the air? Well, the answer is that nitrogen in the atmosphere is N2, or two atoms of nitrogen bonded together. This bond is very difficult to break apart. As nitrogen gas in the air is useless to plants, they really need some way of breaking apart the nitrogen or taking it in once it's already been broken up. And nitrogen can be found as various useful chemicals, at least as far as plants are concerned, as nitrogen oxide, nitrogen dioxide, ammonia, nitrates, more specifically in fertilizer as ammonia nitrate. Nitrogen gas making up much of the atmosphere also manages to filter its way into the soil, where the process of nitrogen fixation begins. While lightning can occasionally rip nitrogen gas apart, allowing it to form nitrogen oxide and nitrogen dioxide, it's generally, however, too rare and too isolated an event to provide enough nitrogen nutrients for plants' constant needs. Bacteria known as rhizobia in the soil can convert nitrogen into ammonia by using enzymes called nitrogenases, which use a combination of iron, sulfur, and molybdenum combined with energy from ATP to power the process. This nitrogen fixation is an energy-intensive process. Logically, it follows on to the next question: what's in it for the bacteria? Well, certain plants, especially legumes like pulses of beans and pea plants, have nodules on their root systems. These nodules provide a safe home for the bacteria, and they're also fed with carbohydrates provided by the plant, and in exchange, bacteria fix the nitrogen for the plant. Before the creation of artificially made chemical fertilizers adding nitrates to the soil, it's been widely known that somehow legumes managed to improve the soil quality. It took fairly modern science to work out all the details. So if a farmer had a poor quality field, or even poor area of a larger field, they often plant a crop of legumes which could both give a crop to harvest but also refresh the soil at the same time. However, if time was short, you might not even have to harvest the legumes. You could just let the crop grow for a while and then plough the whole plant into the soil without missing a year's harvest for the regular crop that they're going to grow in the field. Plants other than legumes can also make use of nitrates previously fixed in the soil in the form of dead and decaying plant matter. As this plant material decomposes, it releases the nitrates locked up in the original plant back into the soil, then can be sucked up by the growing plants. That's why when talking about a healthy soil, farmers and gardeners often talk about a soil which is rich in decaying plant material. Bacteria and decaying plants aren't the only supplier of nitrates to the soil. It can also be provided by animals who either directly or indirectly eat the plants. So animals defecating and urinating on the field can return nitrates to the soil. However, unless the soil is carefully monitored, sometimes all of these methods of adding nitrates to the soil can be too effective and the soil may become overloaded with nitrates. And as a result, most plants will grow fast with lots of big, dark green leaves, but their ability to fruit and flower may be reduced as a result. Now, all of these extra dark leaves may also lead to other problems in growing plants. In order to make chlorophyll in the leaves for photosynthesis, plants need magnesium and other nutrients from the soil, and if an excess of nitrates in the soil increases the number of leaves, in an attempt to grow these extra leaves, the plant may use up all the available magnesium or other nutrients in the soil, causing problems for the plant later on, potentially could even kill the plant. And since energy has actually been used in the creation of these nitrates, they don't remain permanently locked up in the soil, as other than plants, there are more organisms like fungi and soil bacteria ready to make use of the nitrates and produce nitrogen gas as a byproduct. These denitrificators complete the nitrogen cycle, and the nitrogen in the air, the cycle can begin again.